Yay! Okay, we're going to try doing the notes this way because I was really struggling with the Chromebook. Okay, so this is your notes for parallel, perpendicular, and skew lines. This is 1.3. Here we go. Hold on to your hats. Okay, so parallel lines. Boop, boop. Use this little parallel line symbol. They are coplanar. That means they lie in the same plane. You can think of it like this. Okay, and they do not intersect. So if we look over here, they're asking us about line AB. So if we find line AB in the diagram, okay, I see an extra little arrow in the middle. Okay, now I also see a matching little arrow on line EF. Okay, they each only have one. Those little arrows, the matching number of arrows, are used to show that AB, line AB, and line EF are parallel to each other. Okay, so we can put EF in both of these spots. All right, now it's asking us about EG. EG is here. And EG has a pair of little, if it's parallel arrows, are they parallelos? I don't know. It's a dumb joke. Okay, so we can see by the number of little parallelos that EG and FH are also parallel. Those lines are parallel. FH. Okay, and then if they had given us a pair of lines with like 3 little matching arrows, those lines would be parallel to each other. Oops, I want to put FH on here too. Line FH. Okay, now we get to talk about perpendicular. So perpendicular lines, the symbol for that is like a little upside down T. They are also coplanar. So if you think about a plane, okay, I've got one line in the plane going this way and another one going this way. Okay, they intersect at a 90-degree angle. Examples of 90-degree angles that you might recognize would be like a rectangle. Okay, a rectangle has all 90-degree angles for those interior angles. Now, notice what I just did to show a 90-degree angle. I used a little box. Okay, that little box is used to show that an angle measures exactly 90 degrees, that it's a right angle. So we will know if lines are perpendicular if they have that little box. So let's look for some little baby boxes. So the little box right here. So that tells me that this line EG and line GH are perpendicular. And that's this pair. EG is perpendicular to line GH. Now there's another one. It's kind of hard to see because it's at the top and it's drawn in perspective, but there's another box right there. And that one's telling me that line AB is perpendicular to line AE. Okay, now we get to talk about skew. Okay, skew lines are kind of fun. Not only is it fun to say, but I don't know, I just like them. I don't know why. Skew lines are not coplanar. Okay, so you can't, like if you had a piece of paper, right, we have to draw skew lines on a piece of paper, but we have to draw them in perspective. So, okay, look at me for a second. So like we've got parallel, we've got perpendicular, 90 degrees, okay, and skew, like they never touch. They're not parallel. Look at this, okay? If they were in a plane, they would intersect, but they're not in the same plane. One is in front of the other, so they never ever touch. This is skew. They're not coplanar. Skew lines are not parallel, and they do not intersect. Okay, so we want to find some lines that are skew to line AB. So let's look. Oops. Okay. So I'm going to find the first line that is skewed. There's a total of 4 that I can find. If there's more, I'm fine. I'm going to find the first one, and then you're going to find the one that's kind of like it, the second one, and I'll find the third one, and then you find the fourth one. Okay. So the first one that's skew is EG. Now I want you to find one that's kind of like EG and skew to AB. I'm going to put that on the line. Line EG. Okay, hopefully you said line FH is skew to AB. Right? Okay, I'm going to find the third one, and then you find one kind of like it. We'll use a different color green. No, that green sucks. We'll use dark blue. Okay, here's another one. Line CG. Okay, you find that last one. Okay, hopefully you said WH. Give yourself a pat on the back. Okay, so those are all the lines that are skewed to AB. Not in the same plane, don't intersect, not parallel. The last thing we have to talk about are parallel planes. Parallel planes. There are planes that do not intersect. Okay, so look down at the floor you're standing on. Look up at the ceiling. Okay, those represent, the ceiling and the floor represent parallel planes. Okay, they're not going to touch unless you're in like a really weird building where your ceiling comes down to your floor. Okay, so it's asking us about plane ABE. So we have to find something that is parallel to plane ABE. So ABE is up here. That's the top of the box. So the sides of the box are all going to meet the top of the box, but the bottom of the box will not. Okay, so we get to pick any of those 3 letters on the bottom of the box to name our plane. I'm kind of feeling, we could have used W, but I'm kind of feeling CGH right now. So I'm going to say plane CGH. So any 3 capital letters representing points in the plane. Okay, any order. Okay, 3 points to define a plane. Cool. Next. We have to name 2 segments that are parallel to MR. So MR is this one. Now for parallel, we want the little parallel marks, which are the parallelos. Parallel arrows. Okay, so MR has 2 little parallel arrows. So I'm going to look for other segments that also have the 2 arrows. Okay, so I found 4, but I only need 2. So you can name any of these 2. I've got NS, the segment, I've got KP, segment. Okay, without the segment bar on top, it means the length of the segment, and we want the actual segment, so we're going to put the bar. Okay, we got LQ, and, okay, well, we only needed 2, but we've got 3. All right, now we need 2 segments that are skew to MR. Okay, so MR is still in the same spot. Now skew means not parallel. Different plane, don't intersect. So we're going to try to find all of them. The first one I see is NK. NK. So I'm hoping that you saw KL. All right, I see PS. Now I want you to find the last one. Okay, hopefully you see PQ. Cool. We only needed 2 of those, so any 2 of those would be correct. Now we want 2 segments that are perpendicular to MR. All right, so I see some little perpendicular boxes. Oh, I thought I picked orange. Some little perpendicular boxes. Okay, so perpendicular to MR are RQ, segment RQ, and segment RS. Okay, a plane parallel to MRS. I'm going to shade it so we can see it. So MRS is this one kind of in the front left. Okay, so parallel to that would be kind of the one on the back right, this one. I can't see the whole thing. Okay, so we need 3 of those letters from that plane to name it. So it's got a K, an L, a Q, and a P. So I'm kind of feeling KLQ. Okay, so plane KLQ. Make sure that those are capital letters because they're representing points and we use capitals for points. Okay, name 2 planes perpendicular to plane MRS. Okay, let's start with MRS. This one. Okay, if these segments are perpendicular, that means that this face on the bottom, this plane on the bottom, is perpendicular. Okay, and we don't know this yet, but if this is parallel to this, that means that this will also have to be perpendicular to that front face, plane MRS. So that is plane KLM. And plane, kind of ran out of room, QRS. Okay, we get to shade the plane containing points N, K, and R. Okay, so maybe first find those points. N, K, and R. So the easiest thing is to like start connecting them. Okay, and then you can kind of see that this plane would also hit Q. Okay, so we'll just get all 4 of those in there. And then it says to shade it. Okay. Now we have to name a 4th point in the plane containing points L, K, and S. So let's find those points. L, K, and S. Okay, so we're going to do the same thing. We're going to connect our points, and then we're going to see what that 4th point should be. Okay, now I kind of really want to draw a line to R and shade that plane. You see it? Cutting through the middle. I guess we didn't have to shade it. We just had to name a point. So to answer the question, that 4th point was this point R. So point R. Okay, first page done. Oh my goodness. Okay, we're going to do the same thing on this figure. But we're going to go faster because now you're good at this. Actually, if you want, what you could do is pause the video. Okay, try to do this and then check your answers with me. Okay, so name 2 segments parallel to BF. Segment BF, so BF is here. Parallel would be EJ and DH. So EJ and DH, those segments. Okay, don't forget the bar on top. 2 segments that are skew to BF. So here is BF, and we can't have them intersect and we can't have them be parallel. They can't even be in the same plane. So I think CD and ED. Okay, and I think we can find 2 more too. I'm seeing GH and JH. GH and JH. Let me put my little segment bars on those before I forget. Okay, now we want 2 segments perpendicular to segment BF. So here's my little perpendicular box. So perpendicular to BF would be FJ, the segment. Okay, now, this is something that we're going to learn in the future, but if these 2 are parallel, okay, then this one is also perpendicular up here. More on that this week. Okay, so BF and what is that, BE? Okay, name a parallel plane to plane JED. JED, that's this one. Okay, parallel to JED would be BFG, big friendly giant. Plane BF, whoops, that's EG. Okay, you could have called it BCG. You could have called it CGF. Okay, any 3 letters, points in the plane. Okay, name 2 planes perpendicular to plane JED. So JED I drew all over my picture, I can't see. Okay, JED, perpendicular. Okay, it's got to be the top and the bottom. All right, so that is BCD, plane BCD. And plane FGH. Okay, shade the plane containing points C, D, and J. C, D, and J. C, D, J. Okay, I think the fourth point is going to be F, so it's this plane right here. Okay, now we have to name a fourth point in the plane containing points B, F, and H. Okay, B, F, and H. Okay, I think it's D. Do you guys see it? Kind of goes through the middle diagonally. Okay, so that would be plane B, F, and H. Okay, this last part is a review from algebra that is going to help us with the proofs. But to do your homework for this, like that's all of the video that you need to watch. If you want to watch this algebra thing that will help you with the next video, keep watching. Stay tuned. Okay, so we have this problem. This is just to remind you of how to solve an equation with variables on both sides and how to do an algebraic proof because we're going to do some proofs this year in geometry. Ow, ow, ow. Okay, so we've got 74 students currently taking driver's ed, and the class size is decreasing at a rate of 5 students per year. So we've got 74 students in the class, and it's decreasing at a rate of 5 students per year. So that's -5 with an X because of the per year. Okay, so that's half of our equation. 74 minus 5X equals, okay, we want 18 students taking metals. Okay, and the class size is increasing at a rate of 3 students per year. Okay, so we've got 18, but we're adding more kids. 3 every year. Okay, so that's our first statement. How do we know all that? Well, it was given to us in the problem, so for justifications, we can just say given. Okay, now your algebra teacher is probably like uncomfortable right now wherever he or she is because right now we do not have a let statement yet. So let's write a let statement before we get any further. What is X? Well, to find X, we look for the question. And how many years? So we have to let X be years. Whoops, that's missing an R. All right, now we want all of our variables on one side. Okay, so we are going to subtract 3x from both sides. And that gives us 74 minus 8x equals 18. I'm getting my calculator because I've been so stressed my brain isn't working. I don't know what. Oh, that was the subtraction property of equality. That I don't need a calculator for. Subtraction property of equality. Okay, next, we have to subtract the 74 from both sides. Okay, so that gives me negative 8x equals, and what I don't know is 18 minus 74. And I'm not even going to be embarrassed that I don't know. It's negative 56. Okay, that was also the subtraction property of equality. Okay, last but not least, we got to divide by negative 8 to isolate the variable. Okay, that gives us x equals positive 7 years. Okay, that was the division property of equality. Okay, the very last thing we did in algebra, I know because we're doing it right now, my algebra class, we write a sentence. So we say at 7 years, the classes will be equal in size. Bam, bam, bam. Nailed it. Pretty happy with how that went. Hopefully it made sense.